You note down a pipe of 400 mm internal diameter and 100 mm thickness contains a fluid at a pressure of 80 megapascal. Full point. Find the maximum and minimum hoop stress hoop stresses, okay, across the section, across the section. Full point. Also sketch the radial and hoop stress distribution across the section, across the section. Okay. So now for more understanding purpose, you better to draw the diagram. If you draw the diagram, you can understand how to place the boundary conditions. Okay, you can understand how to place the boundary conditions. Okay, so now I will first note down given datas. Okay, now internal diameter is given. Okay, so let us note down di equal to how much? 400 mm. Now radius, internal radius is a 200 mm. Okay. Now wall thickness is given. Okay, thickness of 100 mm thickness. Okay, so T is given here. This is what? 100 mm. Okay, and internal fluid pressure PI is given. It is 80 megapascal. Okay, 80 megapascal. So you need to calculate sigma C. Okay, and Px. Okay, you can say it as a sigma R also. For radial stress, you can take a sigma R. Okay, you need to calculate. Okay, next also you need to sketch the here. Sketch the radial and hoop stress distributions. Hoop stress distribution across the section. Across the section. Okay. Now I'll draw the diagram here. That is what a sectional view of a cylinder. Now in this case it is a pipe. In this case it is a pipe. Okay. Now this is what Ri. Okay. It's subjected to Pi. Everyone agree? Now this is what R0 subjected to P0. Okay. So now what are the dimensions here? Now thickness is 100 mm here. Okay, thickness is 100 mm. So Ri is 200 mm. Okay, Ri is 200 mm. So now what is the value of R naught here? ಎಷ್ಟಾಗುತ್ತೆ R naught? 400 ಆಗುತ್ತಾ? Value of R naught?
300.
300. Okay, R naught equal to Ri plus T, because your seniors have done a lot of mistakes considering R naught. Okay, so now you calculate R naught here. So it is what? Ri is 200, thickness is 100. Okay, so now this is equal to how much? 300 mm. R naught equal to 300 mm. Okay. Now as they have not specified the outer surface pressure, let us take this as equivalent to P naught equal to 0 megapascal. If they are specified, you assume it. If they are not specified, let us assume external pressure P naught equal to 0. P naught equal to 0. So now what are the boundary conditions here? Boundary conditions. Hello. ಸಿ ಡಿವಿಷನ್ ಅದಾರ ಚೆಕ್ ಮಾಡ್ರಿ ಸ್ವಲ್ಪ ಬರ್ಕೊಂಡ್ರಲ್ರಿ ಸರ್ ಅದಾರ ನೋಡ್ರಿ ಅದನ್ನ ಯಾರಿಗೆ ಕೊಟ್ರಿ ಕೋಲೂರ್ ಸರ್ ಕೊಟ್ಟಿರ್ಬೇಕು ನೋಡ್ರಿ ಬಹುಶಃ ಇಲ್ಲ ಯಾರೇ ಒಬ್ಬರು ಕೊಟ್ಟಾರ ನೋಡ್ರಿ ಅದನ್ನ ನೋಡ್ರಿ ಮತ್ತೆ ಚೆಕ್ ಮಾಡ್ರಲ್ಲ ಹುಡುಗರು ಮಿಸ್ ಆಗ್ತಾರ ಅವ್ರು okay. So now what are the boundary conditions here? So boundary conditions at Ri equal to 200 mm. So Pi is 80 megapascal. Okay, one condition. Second condition, R naught equal to 300 mm. Okay, so P naught is 0 megapascal. Okay, now these two values are refers to the radial stress. Okay, these two values are refers to the radial stress. Okay? So let us write equation for radial stress. That is what Lamè's equation for radial stress. Okay, so now Lamè's equation for radial stress. So this is what Px equal to B by x square minus A. B by x square minus A. Now let us substitute based on boundary condition. Okay, so now at Ri equal to 200 mm, so Pi is how much? 80 megapascal. So let us substitute here 80 B by 200 square minus A. Let us take this as equation number 1. Now at a second boundary condition, R naught equal to 300 mm, P naught is 0. Okay, so now 0 equal to B by 300 square minus A equal. Now, so if you gone for subtracting, you are going to get a 1 constant. If you gone for adding, you are going to get a 1 constant, right? You are going to get a 1 constant. Now, so let us go for subtracting equation 2. Okay, because value of Rx is maximum here. Subtracting equation 2. Okay, equation 2 from equation 1. Okay, from equation 1. So let us see what happens here. So equation 1 is 80 minus 0 equal to B by 200 square minus A, okay, minus B by 300 square minus A. Now we simplify this one. So someone quickly simplify and give the answer. So now 80 equal to B by 200 square, okay, minus B by 300 square. Okay. Now we calculate value of B here. You will get value of B. Someone calculate and give the answer. Someone give the answer. How much you got? Hello. Ranjungi, Chowgle, Patan, Srivastava Kulkarni.
5.7 into 10 raised to 6, sir.
5.76
into 10 power
into 10 4 of 6.
6, sir.
Okay. Next, you substitute value of B in any one equation here. You substitute value of B in any one equation, you are going to get the value of A. Okay. So let us substitute. So value of B in equation 2. So what will get? So now 0 B divided by 300 square minus A is there. Okay, let us go for 0 A equal to, so B is 5.76 into 10 to the power of 6 divided by 300 square. So how much you got?
$64.
64, sir.
64. Okay. Okay. Now, so you can calculate the circumferential stress at any position. Let us calculate here first. Circumferential or hoop stress, sigma C, okay, at x equal to 200, okay, at x equal to 200 mm. Now this is what B by x square plus A, right? Now B is 5.76 into 10 to the power of 6 divided by 200 square plus 64. How much you got?
Two not eight, sir.
208 megapascal. Okay, 208 Newton per mm square. Okay. Now, circumferential stress at x equal to 300. That is what R naught. Okay. So here is what Ri. Okay. Now calculate here how much you are going to get. So 5.76 into 10 to the power of 6 divided by 300 square. Okay. Plus 64.
128.
1 128.
128.
Okay, good. 128 Newton per mm square. Now I have calculated the required parameters at boundary conditions, right? So they have asked one more question here. You need to sketch up the radial and hoop stress distribution across the section here. Okay? Across the section. Okay. Now to get the sketch, you need to go for some interval points. You need to go for some interval points. Okay. So let us look out here. I'll draw the diagram. Now this is what the Ri. Okay. Now this is what R naught. Okay. Now you got values of sigma c here, okay, and px here. You got value of sigma c here and px here. But to get the sketch, at least you need another two more points here. At least you need two more points. Okay. Now Ri equal to 200. Okay. So R not equal to 300. So how many points you are going to make here? To get 10 curve, you need minimum 3 points. Okay. So now what I'll do, I'll go for at a distance of interval of 50 mm here. Okay. That is what Rm or Rx equal to 250 mm. Okay. Rx equal to 250 mm. Okay. Now let us calculate the radial stress at x equal to 250 mm. Okay. So now this is what Px at 250 mm is b by x square minus a. So b is 5.76 into 10 to the power of 6 divided by 250 square minus 64. Okay. Similarly, calculate the circumferential stress. Okay. So at x equal to 250. Okay. So this is what sigma c equal to b by x square plus a. Now b is 5.76 into 10 to the power of 6 divided by 250 square plus 64 plus 64. Now we calculate. How much you got here and how much you get here. One. This is what the circumferential stress.
156.16.
156.16 Newton per mm square. So what about the px radial stress?
Twenty-eight point
28.16. Okay. .16. Now everyone solved it or not? Everyone solved it or not?
Sir. Yes, sir. Solved, sir.
Yes, sir.
Okay, now let us look at the distribution here. Okay. Now in some book they have gone for placement of hoop stress on top side, okay, and radial stress on bottom side. Okay. Now the circumferential stress is of nature, it is a tensile. Okay, it is of nature tensile. So draw that value in upper side. Draw that value in upper side. Okay. So the radial stress is of nature compressive. Draw it on bottom side. Okay. Now just look out. Now at Ri equal to 200, Ri equal to 200. So the circumferential stress is how much? 208 megapascal. Okay. So at Ri equal to 250, so circumferential stress is how much? 156.16. Now at R naught equal to 300, the circumferential stress is 128. Okay. Now the radial stress at Ri equal to 200, it is equal to the fluid pressure. It is equal to the fluid pressure, that is what 80. Okay. Next at at R equal to 250 mm, it is how much? Minus 28.16. Minus 28.16. Now here it is a 0. Now we just look out the variation or the distribution of stress in both the cases is of parabolic nature. Both the cases is of parabolic nature. So because you have a variable term x square here, because you have a variable term x square. Okay. One more thing is here, you need to check the value of arbitrary constants. Okay. You need to check the value of arbitrary constants, whether you have solved it correct or not. Okay. It is just a cross check. So now this value of a is of single digit or double digit or maximum of triple digit. It may be in terms of tens, it may be in terms of hundreds, sometimes maximum it may be in terms of thousands. Okay. But the value of b is, it may be in terms of 10,000s, or it may be in terms of lakh, or it may be in terms of 10 lakhs. Okay. Keep in mind, so the value of b is always greater than a. Value of b is always greater than a. If you got the value of b is greater than a, then you have solved problem as 100% correct. Okay. If you got a value of b is less, if you got a value of b is less, then somewhere you made a wrong. Somewhere you made a wrong. Okay, you please cross check that conditions. Okay, right? Okay. So now let us go for next problem. You note down. It's of different here. It is of different. Okay. Okay, you note down. A thick pipe